Yo, 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 what's up, what's up? Welcome back. Today we're working on our x86 operating system titled StreamOS because I developed this OS on Stream. And we've got an OS that, well, operating system is probably a little bit of a strong word for what we have right now. We have a kernel, and our kernel boots in QEMU, virtual machine, and it like boots, it does like memory allocation, it has like concurrency, serial output, unit testing, clock support, PCI support, Ethernet, so like HTTP, all the way up to HTTP. We have like some form of like rudimentary graphics, and USB mouse, PS2 keyboard, and multi-core. So let's just pull open a quick little demo so you can see what it looks like. So when I type this, what happens is it like builds the kernel, it packages an ISO, it like packages grub, a bootloader alongside with it, and then grub will boot our kernel, which is open here. Here we have a little game where I'm playing Brick Breaker. I'm controlling with the mouse or with the keyboard, whatever. We have like some demo of like allocations and stuff. This is getting printed in the standard output of the application, where this is actually like the serial console output forwarded to standard input output. If we open up a browser, we can like go to the web page of the OS, and we have like hello from the StreamOS kernel, and I say hello, and it will like send that back. So we have some form of like HTTP parsing and like response handling, etc. And what we're working on today is Doom. So let me check out the Doom branch, because it's fucking broken. I think I had to compile with cc equals i686 elf gcc, I think. Struggling to remember. And what we've done here is we've looked up this project. Well, I googled like, how do I port Doom to my OS? Because like this guy on the internet, he said that it couldn't run Doom, right? And so that's like a big problem for me because I want it to run Doom, right? I don't want the guy on the internet to be like, your thing sucks, you're wrong, right? Obviously, like, I have to fix that. So I looked up like, how do you get Doom? And I found this like thing called Doom Generic, which is essentially like this like compatibility layer on top of FB Doom that basically says like, well, you should only really need to implement like a few functions in order to get up and running. And so we like pulled this into our build. We set up in our build script, we like look at what's in Doom Generic. We try to compile it, and it turns out that software uses the standard library sometimes. Shocker, right? Who could have seen that coming? But what that means is that there's a lot of stuff that like Doom assumes exists that just doesn't, because we're in our own operating system that doesn't have libc or anything like that. So last stream, we painfully went through every single call to the standard library that Doom makes, and we just stubbed them out. So we like say, any time that you call any of these program or these functions will just crash. And then we started like working through implementing them one by one. And so what we have to do now is actually start iterating through and seeing where we crash. So right now we're getting at this point, we got to the point where we got to like this function snprintf unimplemented, which we called it at because I was like, that sounds like a lot of work. But I think, actually, after thinking about it a little bit, I think it's probably fixable. While we're here, we'll also fix like our printf implementation to be correct, and then we'll just keep going and we'll see where we get. So that's where I want to start. So what are we doing now? The first thing that we're going to work on is printf implementation. Okay, so what do we want to do here? So in C, printf looks like this. Let's see. Let's open up maybe like a little test project, and we'll have like int main void, and we'll say my printf something hello something, and I'll pass in mic, and I'll pass in maybe a number as well. So what this looks like in terms of like how you would implement this is you'd have like a my printf function, and he would take in the format string, which I think is const char format, and then just like a bunch of other shit. And this is like some like magic C syntax that basically says like, hey, we have other stuff, but I don't know what it is at all. So it's like up to you, the caller of the like the function implementer, to like know how many arguments there are and iterate them. So I think if I remember correctly, the way they do this is you include this thing called studarg.h. And you say, well, I have a list of arguments, and I'm gonna like initialize this list. And what am I gonna do here is I'm gonna say, well, my variadic arguments start after the argument format. And then you're gonna like end this. And let's say like, just for the sake of like argument, I guess, we'll say we'll pretend that we know what the arguments here are. So we'll say that we are expecting to get 2 arguments. One is a string. So here I think you say const char star or something. And the second one is an int. And so we'll say like const char star x is equal to this, or we'll call this s, I guess, because it's a string. S for string, obviously. And then int x is equal to this. And if we then go in here and we say printf format sx, we should get what we should get a reasonable print here. Let's put a new one on here. And let's just try this. gcc-o test.c. We're missing include stdio. And he doesn't like va end. I thought that was the function. So I don't have like an indexer set up for C right now. So we're just going off memory. And this guy, so he has va end, and he takes in va list. So what's the problem here? We have van, and he takes in, oh, too many arguments. There we go. Okay, so I type test, I get hello mic34, which is great. And so, like, what the fuck is going on here, right? Like, where are these arguments coming from? And what happens if I just do this again, right? What if I just say, oh, yeah, we're going to have 2 ints in here. And I say this, and I don't pass it in? What happens? Right? And it's like, oh, this actually all just compiles, and I just like get a random fucking number there. So like, what's happening? And the answer is, let's draw this out. So when I call a function in C, well, I shouldn't say in C. In GCC on Linux on x86, I'm pretty sure they're using the cdecl calling convention. And what this guy basically says is that we just pass arguments on the stack. And so when you call a function, you're basically saying like, here's like memory, right? And like, you're kind of like just in memory. You have like this stack pointer in memory sitting here. And he's pointing at like some like local variables and shit. And if I'm going to call a function and my function's like f int float, like const char, like for a string, char star, Jesus. We'll pretend that you can read what that says, because obviously you can't. But like, if you could, it said int float const char. Like, what I do before calling this is I like push my string here, my like float number here, and then my int here. This guy gets like moved down to like over here now, so he's moved. So now this is my new stack pointer, and then I call the function. And so then what it does is he goes like, well, what are like my last 3 on the stack? Well, here's like my first argument, my second argument, my third argument. And if we just like start putting extra shit on the end here, that's what the variadic arguments are. Is like we just like pushed stuff to the stack before we called, and we're like, well, hope you look, right? So that's all we're doing when we do this. Is like, we're just saying like, look at, this is like, look at stack pointer minus n. This is n plus 1 and n plus 2. Brackets missing. Now, where I get a little confused here is the cdecal format says it should be right to left. So I don't actually know how it knows where format is in that scenario. Maybe it's like pushing left. Oh, yeah, sorry. It's pushing back to front. So here, format is like ESP is the stack pointer. This guy is this is ESP minus 1. This is ESP minus 2. This is ESP minus 3. And so what we got here when we just printed like an extra thing that we didn't actually pass in is just like we just like walked up the stack and we're just like looking at random shit in there. We don't know what it is. And so where this gets like kind of dangerous is if I was to like try to print a string there, then all of a sudden you're gonna like try to like just dereference memory and go somewhere and like it's not gonna work right. So we need to implement essentially someone that like parses this format string, and every time he sees like a % he goes like, oh, that tells me what type I should be finding on the stack, and I'm going to look up that type and convert it. So that's essentially what like the printf function is doing. So he's just like parsing format string, walking backwards up the stack, and just pulling the next thing and assuming that what you pass in the format string is like the thing on the stack. Which is why like there's a lot of like dangers around using printf. Like I think there's like a lot of security vulnerabilities around this type of thing, because if you just don't pass in the right shit, then you're just dereferencing invalid memory. Yeah. So I think what I wanted to do is I was starting to want to look like looking at implementing that. So hold on, I've got this open twice. And so what we did before was when we implemented printf, we're like, oh, we'll just write the format string, fuck it. And that would be fine if all we were ever doing was printing to the screen, because in Doom, if they're printing something to the screen, we could just like ignore it. We don't actually give a shit what they're printing to the screen. All we care about is that we can like move our guy around, right? But there seem to be calls to this like snprintf, which like takes the output of printf and shoves it into another string. And so I guess what I wanted to do was look at implementing that. And I think, oh, okay, so sorry, there's the other part of this is that there are printf style functions that start with a V. And you might be like, well, why the fuck do those exist? And I was like struggling to understand that yesterday while I was getting back into the swing of things. But the thought is if you wanted to make like a wrapper type, like void error, you had like the format, and then you had like, I don't know, some other stuff. And say like you knew that you wanted to do something with this stuff, you would make your VA list here, right? The same way we did up here, where you have like VA list, VA start, etc. But then if you wanted to like do a printf thing after, now all of a sudden like there's no way to like forward these arguments to printf, right? Like here, all you might want to do here is you might want to be like prefixing their format string with like an error, right? But now you have no way of like forwarding these arguments unless you already have made the VA list. So all of like the vprintf function is doing is it's saying like, hey, you might have to pass on these variadic arguments, and so like that's how you do it. And it's up to you to call like these VA start, VA end functions. The last piece here is when we've been implementing standard library, part of what we did was we needed to implement these like VA start, VA end, VA arg macros, and we just kind of like copy pasted implementation off the internet, and we didn't really think about what that meant at all. But it looks like what they were doing is they were actually just doing exactly what we needed to do. I think I haven't actually checked this, but it does look like they're essentially saying, hey, take the like address of the parameter you pass in, so here would be format, add 1 to it, so like go past what it is, and then like walk back, like now you have a pointer to this thing on the stack, and just walk backwards. So it looks like it's kind of working, but we'll see. Yeah, all right. So what do I want to do? I think what I want to do is in Rust, probably. I think what I want to do is I want to like implement like a standard, like a printf style parser, and shove that into like a state machine that we call from C to handle like actual printing. Because then we can have like piping to our print, like in Rust print implementation, without exposing that to C. And I think that that's just like, we'll have like utilities that will make this easier, I think. We'll see though. So I think what I wanted to do is I wanted to be like, let's make a struct printf parser or something. And he's going to have some sort of implementation. And the only thing that he's going to have in here is he's going to have the format string, which is a const I8, I think, in this world. And as we like advance our parser, we'll just like rewrite where we're pointing, I think. We'll see. We'll see where this goes. Then what we want to do is we're going to have to like expose this guy to C somehow. So we're going to have like no mangle a pub unsafe extern C function, and we'll call this what are we going to call this? Printf parser new. And he's going to return a printf parser, but a pointer to him. So he's going to say const printf parser. I guess mutable, probably, right? So that's just going to be box new printf parser. And I guess here we actually pass in the format string. So here we return a new printf parser. And we leak him. Does that compile? There's all sorts of reasons why this doesn't compile, but let's see if we can find it. Wait, it's actually complaining about. I think I might have fucked up the snprintf when I was in there a second ago. What did I change? Nothing. So why is he mad? Oh, because I forgot to say cc equals i686 elf gcc, of course. Of course. And now he's probably complaining about something else. Scroll past the like 1,000 warnings and look at the actual useful one, which is that we're not using the alloc crate box, which is just like Rust pointer type. So this is usually like a scope pointer. When it goes to the scope, it deallocates. Here we're saying leak please, which means like, hey, we're instead of like deallocating, just like allocate the thing and then let it out into the world, which means that we're also going to have to make a parser free, which takes in the parser, printf parser, and all he does is he's going to say box from raw. He's going to take the parser, and that's it. Right, because when he goes out of scope now, he's going to automatically free him. Okay. So now, I guess what we want to do is we're going to, maybe we add a function here that's going to call printf, just for like simplicity, so that we can like start proving this out. Instead of trying to like go through all the Doom shit, what we can do is we can go to our main function, and we were at some point trying to start implementing Doom stuff, but instead we'll just call our C function test printf. Sure. And we will put this before our kernel demo, and we'll say that there's a function called test printf that exists in the world. In our fake libc, we'll add our test printf function. So we'll just say void test printf. Takes a nothing. And here we'll say printf, hello, Mick. And we'll just see where that takes us. So cargo check. Oops, we forgot to specify our cross compiler for the C stuff. So just do that real quick. Cargo check, it doesn't compile. Error is probably written somewhere. Nope. Error. Here we go. And he's saying that we forgot to put a semicolon at the end of that. Easy. So where do I look at that? Well, that was in our libc rust thing. This guy just needs semicolon. And let's just say OS is written in Rust. Yep, sure is. It would be nice to clobber all of these warnings. I'll probably look at this. I can forgot to write box leak like this. Oh, I probably have to maybe. Oh no, that's probably right. Yeah, okay. Cool. So now, in my printf implementation, we can create our parser. So we'll say printf parser new, and we'll pass in the format string. And here then we have to free it. So we'll say printf struct parser struct print. How do I use this? Printf parser equals this. And then I think probably then I just have to define these functions. So I'll just say that there is this thing called a printf parser. And we'll say that there's a function, printf parser new, that returns a pointer to this guy and takes in a format string, which is a const char star. And there's also a free function, which returns nothing, but takes in the parser that we created. And this is called free. Hopefully, if we compile this, I think that everything should kind of link together correctly. Okay, and so what we should see is we see me write hello Mick, and we should also see somewhere if I log in here, we can say constructed parser. Let's just see if that comes out. Parser. No, I don't see that anywhere, which is interesting. I would like to, though. I would like to. There's also a failure here, attempt to subtract with overflow, which seems kind of weird. Somewhere there's a bug happening. I think that it kind of seems like something's not working correctly. Like either something didn't recompile or something. We also... What's this complaining about? It's saying that this is never used, but it's exposed externally, so it should be. Oh. Maybe I have to write no mangle here. I'm concerned that my like C function isn't recompiling, because this shouldn't be happening anymore. This like hello Mick, because we're not trying to print anything in here at all. Oh, maybe I didn't save the file. That looks very likely because there's a little plus in the editor. No, that's very odd. I was expecting to see something else. Is hello Mick written anywhere? It's only written through printf. Very strange. Okay, let's try to sort this out a little bit. So let's try to like smash some warnings. And maybe just for sanity, run like a cargo clean, just in case for some reason something isn't getting recompiled. Because I am seeing like, I feel like I shouldn't be seeing this hello Mick printed because nobody in fake libc should be trying to print it, but I'm seeing it, so I'm worried about like some sort of like build order problem happening. That's very odd. Am I calling the right thing? So let's just double check here. If I called something else that I know should panic, right? Like let's just say we should crash. Let's see if we at least see that. Then we can like start bisecting the problem. Okay, so that's a good indicator that there's at least code running that we want running. Now the question is how come when I call printf, it's not running the code that I expect it to run? Right, specifically, it's like it shouldn't be writing that out because before we were calling puts, before in here we had puts format, right, and that should print it. But now we should be calling into these like these functions which aren't printing anything. So where the fuck is like what's happening here? Let's comment out this definition and just make sure that like we should see linker errors, right? Because like that function shouldn't be called, like shouldn't exist. Maybe there's like a duplicate printf entry that I didn't know about. Right, so like the fact that this is like building is very strange to me because I thought printf shouldn't exist because nobody's implemented it. So maybe that there is like a definition of printf hiding somewhere that I didn't know about. If I comment out other ones of these, do we see anything? Something feels wrong. Something feels wrong. If I write in here panic, see, uh-oh. Do we crash? We should. Come on. No, no crash. Something's wrong. There's like, it feels like something's cached that that shouldn't be. Or, because like if this, how do I say this? If this was working the way I think it should be working, we should be seeing linker errors that say, hey, there's a duplicate definition of printf. Like, yo, what the fuck? But instead we're just seeing like an old definition of printf, even after a clean. Which is very, very odd. And I don't know what to do about that. I wonder if any of these warnings are going to give me clues. I guess maybe in my build script, let's comment out the Doom stuff and only build fake libc just for now. Okay, and let's look at maybe running again just to see. He must be linking against like an old version of something. So in our like outputs here, do we have like, instead of doing cargo clean, I'm just gonna nuke the whole target directly. Because I really don't trust it. It seems like there's an old version of the library kicking around that it's somehow linking against by mistake. It's how it feels. No, very, very, very strange. What if I call like something else? Like exit 1. Does that crash like I expect? Yeah, it says exit unimplemented. So why the hell is printf behaving any different? Oh. I bet. Oh. I bet that there's some sort of bullshit where if you call printf with no arguments, maybe it like gets converted into a puts call. Yeah, I bet you. I bet. Um, test printf. Let's see if we can find him in here. So he calls this, which is 210 E5. Get PC thunk AX. What the hell? Oh, sorry. I think that's the old version. Sorry. Let's build again. Let's build her again and then take a look. So it's called test printf. Dude, that's so fucked. Okay, so I think that if I call printf with no arguments, GCC goes, printf, no arguments? That looks a lot like puts, and just like swaps it out. That's fucked. But if I pass in like a 5 here, and then build, and run, do we start to see crashes? Fuck, yeah. Interesting. Okay, so GCC's doing some wacky shit behind my back, or maybe it's not wacky and I just don't understand. But that's wild. Okay, so we'll go back to it trying to create the parser, which was here. And here we'll just make sure to pass in a thing here so that it actually gets called correctly the way we want it to be. And now we should see our printf parser starting to get constructed. This attempt to subtract with overflow is concerning, but we'll deal with that later. And here it says constructed parser. So it does look like we're starting to get, we're at least understanding where code is getting called. Okay. So attempt to subtract with overflow. Let's try to see where that's coming from. So what we can do is we can type GDB equals 1 into my environment variables. And what that does is it, when we type cargo run, we're going through this like QEMU wrapper script that we've written that basically says like, hey, I'm gonna like package the kernel that you built cargo into like a ISO with grub in it, and I have all of these like these arguments I'm gonna pass to QEMU, and you just like pass in. We'll figure it out from here. You'll give us the kernel, and we'll construct the ISO and boot the QEMU and stuff. QEMU has this like option on it to say like, hey, I know where like the program, like the instruction pointer is, and I know where the stack pointer is. And so like I have the information that I need to be a useful GDB server for you. And so when we type GDB equals 1, we ask QEMU to do that for us, and then we should be able to attach like a GDB instance to our QEMU and like get like breakpoints and like proper debugging where like within the kernel, even though our kernel hasn't implemented GDB support or anything. So probably I'm missing a breakpoint in here on this guy. So let's just quickly throw him in here. Cool. And we'll run it again. So GDB equals 1, GDB-x. Let's get moving, and hopefully somebody bitches. Yeah, he's saying attempted to subtract with overflow. But I'm still actually not seeing the breakpoint that I want to see. Fuck, how can I, if the breakpoint isn't getting hit, how can I debug this? He is exiting, so maybe my panic handler, like the breakpoint in the panic handler isn't getting hit for some reason. Can I break on this guy? Maybe that'll do it. GDB-x to run my script. now that crash isn't happening. That's interesting. Maybe it's rare. Or maybe this only happens in debug mode and I just haven't noticed this before. Huh. Interesting that I can't hit that breakpoint. Oh well. I'm gonna come back to this probably. I don't know. We'll see if we can find a better way to debug it later. It could be from how can we debug this? Fuck. It's hard to ignore because it's just like fucking stuff up. Let me check maybe if this was happening before this Doom stuff. That at least helps us bisect. So we'll just commit -m temporary and check out master and cargo run. And let's just see if this is still getting angry. Nothing happened this time. Let's just run it a couple more times since it seems inconsistent. Ah, okay. So this is just broken, and it looks like it's probably related to the mouse stuff. Maybe the USB stuff. So let's maybe go back in time a little bit further. Probably we can go back to 1 before mouse support. See if it's happening there. Give it a sec. Wait for the virtual machine to boot. Yeah, I bet you there's just a bug in like the USB USB stuff. Yeah, okay. It would be really, really nice if I could get my breakpoints working. Because it seems like sometimes they work and sometimes they don't. I haven't really figured out like what the trigger is for that. Let me try like making a breakpoint in main just to see if like that does anything useful. So we'll say in main we want a breakpoint just like before we start the demo. Because sometimes like I need to like breakpoint somewhere before the failure and that kicks it into like a working state for some reason. I don't really understand why. I've just seen that happen before. So let's just try that. That's a breakpoint that we should be guaranteed to hit. And we don't hit that either. That's really odd. Oh, there we go. Okay, sometimes I have to like manually breakpoint it myself first. That seemed to do what I wanted to do. Okay, so here, hopefully we see the attempting to subtract with overflow. Can we say like print panic info? Dot message. This. And can we like dereference the thing in there? Because that's probably like a pointer to something. Yeah, attempt to subtract the overflow. Sick. Okay, so we're in the right spot, and now we can actually see where the problem is. So it's in our multi-processing code. Where we are running some closure in the game. Interesting. So it's in our game logic. So we have now is 896. Next frame time is 895. So we just have to fix it's in our game. If we take too long to render, we just crash. That's fucking annoying. So we'll just quickly patch that up. Next frame time minus now, and so we'll just say if next frame time is greater than now. Is less than now, I guess. We immediately continue. And draw the next frame right now, please. Or maybe we still have to do this. Not sure. That's fine. That's good enough for now. That'll at least dodge the bug. Okay, sorry. A little bit of a sidetrack there. So we'll just say that we fixed problem with crash from subtraction overflow. I don't know. And sometime, we don't know when we did this, but we fixed it, or when we started working on this, I should say. And now we're back to printf implementation at like 40, 45. Back to printf. Okay. So hopefully that's out of the way, and we can go back to our parser. So what do we do here? We construct a parser. And what are we going to want to do from the C code? We're going to want to like advance this guy and pass in pointers to arguments as they come. So I guess we have our VA args, or VA list of args. We're going to initialize him to be a list of arguments after format. And we're going to do some shit, and then we're going to end this. And presumably we're going to like, first the parser is going to advance until he hits a % sign. And then he's going to like maybe request a argument to be passed in. Which seems reasonable. Okay, so, and maybe he'll also tell us like, hey, we expect an argument of this size. That's also seems reasonable. So let's do that. We'll say pub unsafe extern C function parser advance, I guess. Printf parser advance. This is no mangle because we want to be able to be called from the C code. If we allow mangling, then we won't know the name of the function. And I guess we'll pass in the parser. And we'll return an argument size, I guess, right? So we'll return an int, and if that int is 0, then we'll say we're done. But if it's greater than 0, then we know that we have like an element that we need to pass in. And so which means that we'll also need another function that's like printf parser push arg. And this will take the parser as well as a argument, which will flag as a pointer for now. Seems maybe reasonable. We'll see. We'll see how this goes. So here, our printf parser advance is just going to call parser dot advance, which means that this guy needs to have a advance function. Takes mutable self and returns an I32. What we'll say is unimplemented for now. And then he's also going to have a push arg that takes in the constituate argument and returns nothing. And then here we call push arg. We're starting to figure it out. I guess he probably returns nothing. And we have to pass an arg. Okay, so from the C side, we're going to say that we're going to iterate over we're going to like keep asking the parser to advance us. So we'll say while parser, how are we going to do this? We're going to have int arg size equals 0. And we're going to loop probably a do while loop makes sense here. And we'll say do this while arg size is equal 0. And in each iteration, we're going to call printf parser advance. And we're going to assign the output to arg size. And then we're going to say printf parser push arg, which means that we need to get the arg. So here we're going to call va arg, pass in the args. And here is where we're going to get a little tricky. Usually you would say like, hey, I want an int out of this, right? But that means that like internally they're going to call size of int. Let's see. Here they're going to call like, hey, advance this like pointer by size of int. But for us, maybe we want to do like a runtime thing. So we'll just kind of like, we'll say like va arg sized or something. And here we'll pass in the size. And here we'll just increment by size instead of size of type. Right? That seems reasonable. And then here we can implement this va arg as va arg sized ap size of type. I think that works. I think. So this is non-standard, but we don't care because we're in control, in full control. Now, this shouldn't be a do-while loop. This should be a while true loop because we actually have to do the check for the arg size here. So we'll say if arg size is equal to 0, break. Does that compile, do you think? Maybe. We'll see. Clearly not. So what doesn't it like? Error. He doesn't like that arg was undefined here, but that makes sense. And this isn't an arg, this is a... So what is this guy going to try to return back? He's going to return a pointer to type star. What the fuck? So I haven't actually looked at this implementation. I see. So he is saying that, hey, we have a pointer to this thing, and actually go back one and dereference that. And so I guess instead, we're going to want to pull in the pointer to this. So we'll call this var pointer. And let's see. Why are they doing this -1 shit? Where did I get this implementation from? Let's Google this again. Va arg implementation. See, Stack Overflow is probably where I got it. Or maybe it was here. That's not where I got this from. That's not where I got this from. How to implement va arg. I wonder, like, this looks familiar, but this isn't what I was reading. This isn't where I got these macros from. I guess maybe we could just use our brains, right, and try to figure it out, right? This is like pretty fucking clear, right? This is exactly what we wanted, is like what we thought it should look like. So let's use our heads. So this is like going to be the first argument, and so we'll say the first, when we start this, we're gonna move forward by the size of that thing. So what did these go, like, why does this look like this? Param and +1. Okay, so I think that's fair. So he's gonna, like, when we initialize the list, we're gonna look at basically if we have our memory, it's gonna go like format and then like A, B, C. When we initialize our list, we're pointing at the A. right? Because we're taking the address of format and incrementing it by like one size of that thing, and then coming here. Cool. Now when we end, we just clear it. Sure, it doesn't really matter. Now let's get into the nitty gritty. So here, if we're looking at this guy, we say that we have, this is going crazy. So he's advancing. I see what this -1 is. So what he's doing is he's advancing and dereferencing in the same step. So the advancing is like he's saying like, I'm at A, now I'm gonna move to B, and then like, but you still need me to dereference the thing at A. So like, I'll dereference B -1 to get A. I think I understand now. And so if we are trying to get the pointer to the thing instead of like the thing dereferenced, we still do that same advance thing, but then we just don't dereference the result. So here, this is the advancing. This is the casting to the pointer type, which we don't actually care about here. So in our case, when we're trying to get the pointer, we'll say that this is we'll always cast this to a car star, because car stars are always valid. And then we just don't dereference. And then here on like the normal VAR stuff, hold on. We actually do shit. So in the size version, if we're trying to get the pointer to the thing, we actually still do need to subtract 1 from the thing. So here we have like this expression that's us incrementing the thing. But here we're incrementing by size. And then we don't cast back. Oh, these brackets are so hard to parse. Holy shit. Okay. So then we just say minus size here's. And that should give us back the original pointer. And then here, when we're trying to dereference it, we just cast var sized AP size of type. We cast that to the type we want to dereference, which should be easy. There we go. I'm pretty sure that's right. Pretty sure. But I guess we'll find out when it breaks. Okay, so here, now, we can call this like maybe size var pointer is probably maybe a nicer word for this. Okay, there we go. So now we get the size of the argument from our parser. We say const car star arg is equal to that thing, and then we pass that arg to the parser. And we shouldn't be const, so we'll just make it a car star. Now do we build? Obviously not, right? Because we're incapable. True undeclared, so I think we need to just include std bool.h or something. Something like that. There we go. Cool. Cool. And now we're seeing a not implemented, which is because we're trying to call printf parser advanced, and that doesn't exist yet. Cool. So I think that's it. So I think now we can just focus on the Rust side. So here, we're going to look for the first occurrence of either a null terminator, because the format string is terminated by null, or a %sign. So, and we'll print everything up until that point. So we have like self format string, and we need to print this guy. So we'll say, we have this guy up until a %sign. So we'll say, let start is equal to format string. And we'll just say while self dot format string, or we'll say let character is equal to the dereference thing. We'll loop here. We increment format string. So we say self.format string is equal to format string add 1. Right? And then all of this has to be unsafe. So we'll just put it unsafe here. And now if we're at either a null terminator or a %sign, we have to do some other work. So we'll say if car is equal to %, do figure out the size of the operand and return. Otherwise, if car is equal to, sorry, I can't just write a %sign here. We can just put that like this. Sorry, I have to cast this to E8 as well. Otherwise, if the car is equal to 0, we return 0. And here, we just have to figure out the operand size. So right now, I think if we return 0 here, for now, what should happen is we should print up until the format string. As long as here, we actually did some printing, which we're not doing right now. So hold on. We'll say let mute ret is equal to 0. Here we'll break. Here we'll also break. Here we'll return ret. And just before that, we will print everything up until the new format string. So we'll say print. And here we need to print everything up until that point. So we'll say what? Let s is equal to core stir from UTF-8 unchecked. Then we need to create a slice. We'll say let s is equal to core slice from pointer range from raw parts. Yeah, which is from start to the distance from start offset from format string. So this is actually the format string offset from start is the length. Cool. Then we convert that into a string. And then we just print the string. We also need to convert this to a usize. So we'll just say try into expected positive size. Maybe this needs an ampersand? No? What is he? He's SI8, but he's being SU8. So we'll just say convert these guys real quick into U8 pointers, even though the C side is I8s, signed versus unsigned. Maybe we should just do everything as U8s here, and that will make our whole, like, everything in our life easier. So just when we do this guy, we say let format string. Maybe we don't even have to say I8 here. We'll just assume that they passed us a U8 pointer, and then I think everything else just works for free. Okay, so if this builds and runs, we should see a print of everything up until our first argument, which we're seeing. We are seeing hello Mick followed by nothing, which if in our printf stuff, we say hello Mick, and then we try to pass an integer, and the integer just isn't printed. And so what we should be able to do now is we should be able to, like, specially handle %d for now until we're like trying to do more. And yeah, figure it out from there. So we'll just say I guess here we'll just assert that self.format string add 1 is equal to the byte string of D, because we're assuming that's what we're going to see. Yo, found your YouTube vids, great series. Yeah, thanks, appreciate it. Glad to have you here on the live side. So we're going to see a %d, and if we see a %d, we should return that we expect a 4-byte thing. And we should, but before we do that, we should say ret equals 4. We break, and we also have to advance the pointer. I think 2 in this case, because we have a % and the D that we're trying to bypass. And then, when they push the arg, here we should know that the last thing that we were like expecting an int. So how do we do that? We just, in our parser, we also store expected arg. And here we will, well, no, actually what we'll do is we just won't advance the format string. Yeah. Because then we can like reverse engineer what argument we expected based off the format string. So here we just won't do this. Here we will say, we will move this, we will do this again, where we will take our current position in the, we'll say self.format string. We assert that this is true, and then we assert that this is true, right? We're asserting that we have the %d. Unsafe, because Rust is unsafe. And then we just assume that the argument that they passed in isn't a const u8, it's a int pointer. So we'll just say arg is arg as const i32, and we probably print that. Just for now. And I guess we don't do this. We just dereference it. Okay, so hopefully now when I run this, we actually see hello Mick 5. He doesn't like this. This assertion failed. That's interesting. Can we maybe print out what it was instead? Maybe here, if we use assert eq, he will give us a better message. Left 255, right 37. Sick. Let's think about this again. Thinking. What am I missing? Here we see a %sign, and we break out. And then we call push arg, which should come into here. And all of a sudden it's in a different state. Like, what's up with that? What is up with that? I guess here we'll just print line self format string is equal to this. And just make sure that it's the same when we come back in. Just for sanity. Okay, so that's a pretty good indication that something's like fucking wrong. So let's double check here. Yeah, we just fucked up hard. So here, like, first of all, this function isn't even defined. How the fuck is this even working? I guess there's like implicit function declarations that it's just allowing us to use, which is pretty fucked up. Let's, I guess, actually put these guys in here. So we have push arg, which takes in the printer as well as the arg as a const char. And we have the advance, which just takes in the parser. And this guy returns an int. I guess we can size him just for sanity. Hopefully now this works a little better. Hey, okay. Let's get rid of this, these extra prints. And see what we get. Okay, so we've got a lot of extra printing. Why is that? Oh, probably because I didn't advance the parser here. So here we just say self.format string equals self.format string add 2. Because right now we're just hard coding the fact that it's a %d in here, and we'll deal with the rest later. Hello, Mick 5 new line. That's wonderful. Wonderful. Okay, so here we've got like a kind of like bare bones. We've like proven like the API works, right? We've like in Rust we're parsing the format string, and in Rust we can then like start parsing a little bit better. And we like go back to CLAN and we say please pass us an argument of this size, and we're like getting that number in. So that's pretty fucking sick. And so now the question becomes like, well, how do we deal with the format strings? So I actually don't know what the rules are here. Like, are they do they always follow with a space? Let's see if CPP reference will tell us. Here we go. So the following format specifiers are available. Does it say, okay, the introductory % character, 1 or more flags, a bunch of optional stuff, conversion format specifier. Okay. So what are the conversion formats specifier here? So these are all the options. And so I guess maybe initially we will just assume that there's none of this other shit, right? None of all of these optional things, and move forward with that. So I guess we'll just say here we will say maybe we have a function that's like unsafe function parse format specifier. And I guess this doesn't have to be a member function here. This can come outside. And he will take the current position. So we'll say S is a const U8, and he will return a format. We have an enum format, and he's gonna have like int, maybe. Right, sure, right? So he's gonna see %d, he's gonna return int. But maybe we also want to return how far to advance the cursor, because if there's like a lot of other stuff in there, right? There's like, if you have like %LLD or something, we need to know to move forward by 4 characters. So maybe we'll say struct parsed format specifier, and he'll just say I have a length, which is a usize, as well as a format, which is a format. Easy peasy. And then this guy will just return a parsed format specifier. So I guess for now, we just advance S by 1. So we'll let format car is equal to S add 1. Match, we will match the dereference of this guy. And right now it's just if he's a D, right, we return an int. So we'll say let format is equal to this, and here we'll just say format int. Otherwise, we'll say unknown or something. That's the other option for now. And for anything else, it's unknown. And because we are only parsing, that's assuming that the next character is always the format specifier because we're not handling the optional shit. We can then just throw in a 2 for the length. So we'll say parse format specifier. He's of length 2 no matter what. And format is the format. I saw on YouTube, and there we are. Welcome to the live side of things. Okay. So when we push the argument here, we'll reparse the format string. So we'll say let format is equal to parse format specifier. Sorry, and we'll pass in our current location. And then we'll, depending on the argument, we'll cast it differently. So we'll say match format.format. If we see format int, we print casting to an int32. Format, sorry, I misspelled that. And otherwise, if we see an unknown, we'll just fucking crash. That seems reasonable. Panic, unknown, format specifier. And I guess we should probably say what the specifier was. So we'll just specifier. And here we'll say that unknown has a specifier attached. And here we'll say that the specifier is a U8 for now. And here we'll pass in specifier and we'll propagate that. All right. Then we advance by the length. Cool. And then up here, we'll also just say we will do the same thing where we'll parse the format specifier. And here we'll just say that the return value is like the size depends on the format. So we'll say ret is equal to format to size. Right? And then we'll just implement that. So we'll say impl format. And we'll have a function that's like to size. It takes itself by reference, and he returns a I32, I guess, because that's what we're returning outwards. And we'll just match self. And if we have format int, we return core mem size of. Is there like a core FFI C int? Man, that's kind of nice. Oops. Then we do comma, and anything else we return unimplemented or something. I don't know. He doesn't like that this is not as I32. Ah, what did I just do? I pressed some buttons I didn't mean to press. But I think we're good. Okay. All right. So let's run. So I think that we should have no errors with our %d, which is great. We say hello make5. Oops. Which is what we typed in over here. And now we can just kind of throw in like a %d again, like just make sure that if we do a few of these guys, maybe followed by some extra stuff, all of this should still print kind of sanely. Nice. Hello make543, some extra stuff. Cool. And then let's try pressing in %s. And here we should see an assertion saying probably that the size is unimplemented. That's probably what we're going to get. Yeah, we're seeing a not implemented when we get to the %s. Which means here we just have to handle this. So here, if we see a %s, we say this is a string. we now have to say that the string exists. And now probably somewhere else where we're using these guys, we have to say, well, what the fuck is a string? And this is now a pointer to a C car. And probably somewhere else we're using him. Down here. And here, we have to get a little crazy. We take the argument they pass in, and he is already a const do8, and so we just have to say C string core f of I C stir from pointer arg, and then we say C stir 2 bytes, and we print this unchecked. So we'll say this is this as a core stir from UTF-8 unchecked, I think is what it's called. And I think we're cool. I think cool. It doesn't like that I'm missing another bracket here. Pointer arguments to this function are incorrect. What doesn't it like here? From pointer should be a const C char. Oh, so let's just say as const I8. Cool. So I think that's probably enough for it to print the string now too. Right, so we have an assertion somewhere that it's always %d, which we're not gonna have anymore. We now support other stuff. Like a %s and only a %s. But we are, okay, so we're getting farther. Some extra stuff, %. So here, our size thing maybe is not correct. This two sizes that gets the size of the thing, but we're probably not advancing by the right amount. So here, probably format length might be wrong, but the length is still 2, so why aren't we advancing by that much? Maybe the string we're printing is garbage. Let's take a look again. Some extra stuff, %, and that's all we print. So let's look at what we're actually trying to print. We're trying to print some extra stuff, %s, with a test string subbed in. So it must be something about this guy. So when we normally, what do? We advance the string by the length, and then we try to print the pointer. Oh, it could be, I wonder if the pointer that we're printing is wrong. Let's take a look at that. So maybe we'll set a breakpoint here. And we'll say, in our GDB run script, we'll breakpoint at this guy. And then we'll run this in GDB. We'll source our GDB script. And we'll just make sure that the breakpoint wasn't hit, because I think I actually have to hit sigint once just for it to like trigger. Yeah, here we go. No, he still doesn't. That breakpoint still isn't hitting. Fuck, not this shit again. I just want reliable breakpoints, man. Why is that so hard? Target debug kernel, that's the right thing, I think. Can we just like B kernel main or something? I just want something to prove that it's right. That's so odd. Can I like, I wonder if I've like fucked up the QEMU command line or something. Okay, whatever. We'll dodge this for now and just try to like maybe we'll print. Let's think. I guess I want to see what this argument is and if we're getting the right argument from it. So I guess maybe we'll check the size. So the size should be 4. So let's say print line ret size is this. We should be seeing a 4-byte pointer for the string. Oops, let's turn off GDB because it's fucking broken anyways. So we're seeing ret size 4, ret size 4, ret size 4. Okay. So that seems reasonable. And now on the QEMU side, or sorry, not the QEMU side, the C side, maybe what we should do is we should how can we try, like, can we just put that thing? That seems reasonable. So down here, somewhere, somewhere, can we just, like, put cster or something and see if that behaves any differently? Arguments this function are incorrect. Oh, I see. This should be arg as const i8. Let's see if that works correctly. And if that does, then we're making a mistake somewhere else. I see. He doesn't like this. He says there's a UTF-8 error on this. So I wonder if we can, like, print what we see here. Let's think. So it's very possible that the argument that we're getting here is, like, aligned in some way that we didn't expect. It's possible. So we know that the arg pointer is, like, getting incremented reasonably because we see 543 that we pass in, right? 543. And so it's really just like this passing in of test that's a problem. So how can we check that? Let's look at our standard argument implementation again, and he does this shit where he, like, assigns the guy and then he subtracts the size. Here we should see a size of 4, so we're passing in 4 here, so we're incrementing by 4 and then getting the pointer to the thing back where it was before. Oh, this is a pointer to a pointer. So this should be like this, as pointer to i8, and then we dereference it once. Aha! Right, because we are what's going to be passed on the stack is not the string, but a pointer to the string. And then we have a pointer to the thing on the stack, so we have a pointer to string to string. Nice. Just quick little bug there. No biggie. So here we'll just come back to this guy and throw another const on here and then dereference him. Very nice. Double pointers. Very fun. Cool. Okay, so I think that we're kind of in, like, enough of a spot now where we could try running the Doom generic stuff, and it will start telling us how we're fucking up, because we'll crash in all the cases where it's giving us something that we don't support yet. So probably if I go back to our main function, somewhere we used to be trying to call Doom generic create, and now we can run this and it'll fucking crash. Could not compile kernel due to previous error, because we probably in our build RS earlier, we commented out the Doom generic stuff because it was a pain in my ass, or too many warnings. Now when I compile, hopefully it runs. And we have a not implemented. So here, I guess we say unimplemented, and we'll just put in unimplemented to size for this. There's a bug in there. Maybe I'm not allowed to put this in here. Yeah. So I guess this should be format unknown with this. Okay. Let's try it again. We run it. Hopefully we get like a better unimplemented error. Not implemented. Unimplemented 2 size for 112. God damn it. Can I say this? DS car. Will that make it? Star DS car, I guess. I just want like a letter, not a number. Okay. Yeah. Okay. So unimplemented 2 size for P. So P is pointer, I think. Let's double check that. P is pointer. Cool. And so then we just have to start throwing in pointers. So this string and pointer are actually the same in the context of 2 size. But string and pointer are different in the context of actually printing them. So P goes to pointer. And here, if we see a pointer, we should be doing like, I don't know, like print the argument. So the argument is still probably going to be a double pointer. We're going to have a pointer to a pointer on the stack. So here we just do this and print the arg, I think. Right, so we have like a double pointer, a pointer to a pointer. We dereference the pointer to the pointer to get the pointer, and then we print that. Does everyone follow? Of course you do. That was easy to follow. Pointer to pointer to pointer to pointer. You know? Hey, cool, zone memory, and we actually did, in fact, get that pointer logged, and now they're complaining about %x missing. So what's %x? Unsigned integer into hexadecimal representation. So I guess here we just start stubbing that in. So we have hexint. Hex, we'll just say, I'll fucking call it hex. We'll call it hex. And here we'll say format hex is the same as format int. Right? Those should both be on like, I assume. Yeah, unsigned integer, so the same size. And then, like, where's the rest of these guys we've planned? Here we need to map x to hex, and we also have capital X. Are they any different? It looks like they're just they are different. So we'll only do the lowercase for now, and if we get the hex thing, we just print as, we just, you know. Print the X, print hex. Easy. Easy, easy, easy peasy. And I don't know if it's leading with a 0x in here. Precision 0, no characters. In the alternative implementation, 0x or 0x, what's alternative implementation? Okay. I guess that's not by default though, so we'll just print them as hex. And that's pretty cool. We're like starting to see a printf that works, and the bonus here is that like we've implemented in a way that if we're going to implement snprintf, we can just reuse the same parser, and instead of logging directly, we'll like adjust it to output to a buffer or something. I'm gonna take like a 1-minute break to go to the washroom, but I'll be back in a sec. Just give me a minute. And we're back. Okay. So I guess the next thing to do here is probably to start working towards this like snprintf implementation, right? Like we'll just start popping the same thing into this guy and see where that gets us. So let's just quickly commit and say checkpoint really shitty. No, I won't put that in the message. Really poor printf implementation. And let's see, what do we have to do here to like adjust the output of this guy, right? Because he's going to have like multiple modes now, right? He's either going to be printing to this guy or he's going to be printing to like a buffer. And really like maybe print isn't what we should be doing here. We should be using like, we could use like the write macro instead, which is Rust's way of saying like, go to this specific output, and we could just write to our standard output writer. Then we can just swap out the output writer for like a buffer writer, and that should all just come for free, I think. But we'll see. So let's think about this. Where does that go? So in our IO module right now, our printer, when we call, I guess this is our print macros. When we call print, he is turning that into a write on a printer, and that printer is the printer that we have registered in like static memory globally for our kernel, which is, I think, where is that guy? IO mod, where printer is just a heap allocated dyn write. And in the case of sprintf, I think it's just like a pointer that you write to. Maybe here we can like man snprintf. So he just has an output string, which is his first argument. Easy. So I guess our printf, I guess we shouldn't call this parser also. Printf parser seems like the wrong word. Maybe we'll call it like printf writer. And inside, we're going to adjust him to take in a writer. And maybe a box dyn write is like an okay thing for him to implement, to like write to right now. So we can either use the like standard output printer, or we can use, yeah, just anyone. Making this like runtime, what's this called? Runtime dispatch? Instead of compile time, like making it a dyn write instead of a write, instead of doing like W is write and then passing in W. I think that makes it easier because like our different implementations won't have to call, we don't have to like pipe new functions in. We can just say when we call new, we'll just ask for what type of parser this is at runtime, and that'll make things a little easier for us. Speaking of, how are we going to handle that? I guess we'll say type is an i32, and depending on the type, we'll fill in the writer differently. So I guess we'll just say match type, and we'll say if it's 0, we will get the printer for our global standard output. So we'll say create IO printer, and like, how does a print macro work? We'll just copy paste what they do. And by they, I mean me, because I am they. So I guess we just do this. And what the hell is this type? Let's just wrap this in some brackets real quick, just so I can like double check. So this is a mute option box dyn write, and I guess we say we'll call this like stood out. We'll say if stood out is 9. Now we'll say match stood out. We'll say we'll reassign it to itself. We'll take the name back. and we'll say that if he is a none, like there's no stood out ready, what are we going to do in that case? Maybe we just return a null pointer. This doesn't matter. This is like going to be a thing that actually happens. And we'll say it's up to the caller to check if we actually successfully constructed. Otherwise, we just return the value. Okay? Which means that here we have a... Hopefully we have a like box dine, right? I think. What is this? What is the type of this guy? He's a and mute box dine, right? And shit. I guess that means that this guy can't be a box dine, right? Unless I can put a pointer to the pointer. Maybe that's okay. We'll try that. So we'll say box new stood out. And otherwise, we'll just say we're unimplemented. So for any other type, we'll just return or pointer null mute. And here, we'll say let writer is this guy. And hopefully we should be able to just pass writer in here and everything will work out. Let's see, does he like that? Cargo check, does that compile? Nope. Why the fuck not? Error occurred. GCC did not execute successfully, which means that we should be able to find like an error string somewhere. How is this happening again? Conflicting. Oh, because I forgot to fucking set my compiler. God damn it. CC equals cargo run. All right. So that doesn't compile for another reason, which is probably a more reasonable reason. Because we don't have core format right. So let's just quickly import that guy. We have format right, semicolon, cargo check, but this time we set our CC equals i686 GCC elf. Nope. i686 elf GCC. That's what I'm looking for. And we're still erroring, so let's just see what that's talking about. Trait right is not implemented for box dine right. What the fuck? How is that possible? And mute W required for this. Required for the cast from box and mute box. Oh, I think I forgot to dereference something probably. Does that work? No. What am I missing? Trait bound box, dine right, colon right is not satisfied. God. So, do I have to like double dereference this? Oh my god. Like why? Why? Doesn't have a size known at compile time. Can I like, I'm just trying to get like the inner thing out of this. There we go. That's what I want. So this is converting a, like what stood out here? He's an and mute box dine right. This is like dereference to get to a box dine right. Dereference again to get to a and mute or a dine right, and then a and mute to get to an and mute dine right, and then we put it in a box again to get to a box and mute dine right, and then yeah, which implements right, which is like a lot of juggling, but I think that gets us into the right spot. Pretty sure that's what we want. I'm pretty sure I don't have any like extra indirection there. We'll see. Oh, maybe we won't see. Maybe we'll just live with it. Okay. So now what we want to do is we're going to replace all of these prints that we see in this class with a write to self-writer. I think. Does that compile? Obviously not. Because I didn't write cc equals i686 elf gcc. But if I do write that, it compiles, but it says like, hey, what the fuck, you're ignoring results. And we'll just say like, unwrap, I guess, for now. Normally I would try, well, I should try to do something a little more intelligent there, but this is a fucking meme to make a Doom run, so I really don't, like, this is not gonna live forever. And so I'm okay with, you know, taking some shortcuts for now. What's it mad at? Because I didn't write self.writer everywhere in here. Self-writer. Self-writer. Here we need self-writer, and here we need self-writer. And I think that's it. Cool, that compiles, and can we run it? If this still runs and prints something sane, then we have a really good indication that this will still work. But it's not. It's fucking broken. Okay, let's think about where, so no handler for interrupt 6. That means that like something's like really fucked up. CPU exceptions, OS dev. Someone's got a list of them somewhere. Number 6 is invalid opcode. Wow, that's like super fucked. Great. Let's go back and just only handle, like, try just the one. Right, we're only going to replace one of the prints, and we'll see if we still get, like, hella fuck up. Yeah. He does not like that at all. So if I go back to, like, the print here. If I go back. Wait a second. What's he mad about? Non-null, new unchecked, required, so the pointer is non-null. Is it because of these, like, nulls that I was returning on new? I guess here, how do we check this? We'll just say, print line, we did it. We should be getting to the end of that function. Or not. So who here is feeling, oh, because we're not fucking passing in the type. God fucking damn it. God damn it. So in our fake libc, we have this like definition of parser new that just doesn't match what we expect. We have to pass an int as well. And when we construct this guy, we have to pass in a 0. And then we should stop dereferencing nulls. Everyone should be happy. Oh, thank God. Okay. So now we're printing, this is like getting past where we were before. We're still seeing like a printf of something like sane. And now let's go back to replacing those prints with writes. So we're going to say, search for the word print. And go here and add self.writer and go back to this. Fuck. We're going to say, replace this with write. Write to self.writer. And go back a little bit and unwrap. Then I can look for prints and I can just run that macro. And all of those guys are replaced now. We should compile again. Hopefully we don't fucking crash. Let's go! Okay. Okay. So now we are writing to a dynamic writer. And so now what we should be able to do is, if our type is something else, we should be able to instantiate a buffer writer. Ah, fuck. So the problem is that we actually need to pass in the pointer to the string we want to write to. So we actually do just need multiple new functions. Fuck. Which means that we can actually do the compile time version of this, probably. Can we? No, because the pointer that's returned, we need to know the type of it. And we don't want to like add different push arg types. Okay, so this is still fine. This is still fine, but we'll just say here, this is a new with buff. Okay. So the default parse that we get, we'll write to standard out. So we can remove this like type parsing and just try to do this. I think it's like this. What have I fucked up? I've deleted the wrong amount of code. Oh, it's because I'm still in a match. Here, delete this, delete all this. And this, here we go. So now we assume if they're asking us for this version that we're gonna try to find standard output, we assign the writer, and then we create the writer. Cool. But if we're doing new with buff, we still try to construct this guy, but we need to find a different writer. So here they're going to pass in the format string as well as the buffer, which is going to be a mutable I8. Yeah, okay. And I guess we'll just, I wonder if like a mute I8 implements write. Almost certainly not. So we'll have to implement some sort of write type for this pointer, maybe. But if we say new with buff and he has to pass in a size as well, then we can say let buff slice is core slice from mute raw parts. His pointer is the buff. And the size is the size. Perfect. I think it's like this. And then the writer is just going to be this guy. So say let writer is a box new buff slice. And I think that will compile. Here we'll say new with buff, and we pass in the buffer, which is a char star buff, as well as the size, which is a U size, which I actually don't know what the width of that is. So we'll actually just say size is a U32 so that I can type U int 32t size here. And then here we should be able to say parser new with buff. Oopsies, wrong one. We want to put it in this one. With buff, the buffer is the string, and the size is the size. And we're chilling. So we have an error somewhere. Of course, there's always an error. Write is not implemented for U8. Oops. What is the type of this guy? Isn't he an mute U8? Do I need to like mute this again? I thought that mute U8 did implement write because I thought that it would just start at the position of the start of the buffer and like advance itself forward. But maybe not. Maybe you can't just write to a buffer like that. Implementers. Yeah, I guess not. But it's okay because I can just stick a cursor around them probably, and that's probably. Or is it buff writer? Hold on. Where was I? No, I want to scroll the implementers. Here we go. Vec U8 does implement it, but the U8 buffer doesn't. I have to wrap it in a... Oh no, here, this is what I was looking for. Write is implemented for MU8 by copying into the slice over its data. Note that writing updates to the slice point to the yet unwritten part. The slice will be empty as complete overwritten. If the number of bytes written to exceeds the size of the slice, blah, blah, blah. Maybe I do want cursor. We'll try cursor. Let cursor is equal to core. Oh, fuck. Is cursor only in... Oh, alloc? No, is it only in standard library? Which I don't have. Fuck. Oh, maybe I only want like core IO, right? Maybe. Oh, I want core format right, not core IO right. God damn it. The fact that there's multiple and they're different is confusing. So who implements a SI? String, OS string. Am I high? What the fuck is going on? So how is... Hold on. Which one of these, like, multiple things am I using? Am I using core IO right or core format right? Printer is dying right from format. Ah, okay. That makes more sense. Which is only implemented for a few things. So I need to probably convert the buffer into an OS string or something. Or implement right myself. Or make my own little cursor type. Okay. That gets a little complex. We've been at this for an hour 50. Which means that if we were to try to like do the sprintf stuff, I think that we would go well over 2 hours. So I think I'm gonna call that today. I think we've come into like a pretty good spot where like our printf, like our formatting stuff is like starting to come together. And we can come back tomorrow and we can handle the like dynamicism, is that even a word? Where we like try to write to a buffer as well. We'll start implementing the sprintf style versions of these. And hopefully we'll get a little farther on Doom in it, because that's where we're crashing right now, right? If we cargo run, we can't compile right now because I fucked everything up. But snprint is F. I think this is where, oh, fuck, unimplemented. Come on, here, yeah. They're saying snprintf is unimplemented, and that's where we're crashing right now. So, once we translate this to support like written to buffers, we can use the same printf formatter thing to implement this, and we'll get a little farther. Yeah. So thanks for watching. If you liked what you saw, I stream most days at around like 1 or 2 p.m. Pacific time I shoot for like between 1 and 2 hours. I think longer than 2 hours is gonna make a shitty YouTube video. People won't watch long enough, and under 1 hour is kind of not enough to get anything done. So just try to stream most days for around 1 to 2 hours. And if you're watching on Twitch and you miss live, there's a YouTube link in the Twitch description. And if you're watching on YouTube and you want to pop by and say hi, there's a Twitch link in the YouTube description. In YouTube, I'll link the GitHub repository associated with this project. I try to push like the more polished versions of what we've implemented. So what you see every stream won't necessarily make it in there in its current form, but you should see something that resembles what we wrote here. Yeah, thanks for watching. Catch you guys on the next one. Bye!